So I think the seats are getting filled, so welcome and thank you for joining our webinar, Android for Your Embedded Project. My name is Peter Hauk, Director of Sales at Boundary Devices. Joining me today are Software Team Lead, Gary Bisson, and from Kinetics, Nicola LaGloria. All listeners will be in listen-only mode, so please use the questions section on the main panel at any time during the presentation. We will review these at the end. The presentations are also attached in the handout section. And now, on with the show.
Thank you, Peter. So I'm Gary Bisson, and we're gonna go over quickly the agenda. So first, we're gonna do a quick overview of the AOSP architecture. Then we'll see how Android can be a good match for your embedded project with the list of pros and cons, as well as some case studies to truly understand those. Then we'll cover what Boundary Devices solutions are regarding Android. And finally, Nicola will present how Kinetics can help going further with your project. So if you have any questions, please skip them until the end and we'll try to answer them. So the first question that comes to mind is, why are we here? So let's start with who Boundary Devices is. We are a supplier of ARM-based single-board computers and system-on modules located in Lake Forest, California. All our boards are proudly manufactured in the US. And although we offer off-the-shelf platforms, we specialize in custom solutions. And we are now an NXP Gold partner, as we've been doing this since 2003. So why are we talking about software then? Well, software is the key to any embedded project nowadays. It is at least as important as the hardware. That is why Boundary Devices offers many options when it comes to software. Whether you want to use Linux with Yocto, Buildroot, Debian, or Ubuntu, or Android, which is the topic of this presentation. So what is Android? Well, the OS doesn't need to be presented anymore. It is now the most used mobile OS, as it has more than 70% of market share as of last April. But the main reason we are here is because of the Android Open Source Project, or AOSP. That is thanks to this openness that the OS got traction across vendors and across industries. Note, however, that this isn't a regular open source project driven by the community, but it is rather developed by Google behind closed doors. It means that Google provides its source on release dates, but in between releases, it's hard to know what's going on and what feature will come up. Also, Google doesn't open source its own proprietary application, obviously, like YouTube, Gmail, Play Store, and so on. So the AOSP experience is pretty bare compared to Android as you know it on your phone. And although it is clearly used in the mobile industry, it is not getting as much adoption in the embedded space. So we'll try to see the reason why and what it brings to the table. But before looking into the OS architecture, I wanted to give a few disclaimers. First, I'm not trying to convince anyone that Android is the solution for every project, because it is not. Instead, an OS for an embedded product has to be chosen carefully and depends on many different factors, like do you have an existing product that you're evolving? Do you have an existing source code that you're trying to keep as legacy? What are the skills of your team? And what are your address constraints? So all of those are questions that you need to ask yourself when choosing your operating system. And really the goal here is to give you pointers on the benefits of using Android and how to use it properly. And since we're talking about the AOSP in the embedded space, we're not going to cover any Google related aspects such as GTS, which is the Google Test Suite, or the GMS, which are the Google Mobile Services. So now let's have a look at the Android architecture. The main thing that you're going to hear when it comes to Android compared to other Linux operating systems is that it is based upon the Linux kernel. That is a great thing for many reasons, but especially because so many platforms are already supported and so many drivers are already supported. And Android used to have many custom batches on top of the regular kernel, but this batch set is reducing more and more, as the goal is to upstream as much as possible. That is why if you compare like the Android branch of our Linux kernel to the Linux branch, they are very close to each other, especially when it comes to the driver and the device tree, they are identical. But apart from that, apart from the Linux kernel, pretty much everything has been redesigned. Even the C library, which is usually a glibc for Linux OSs, is different. It is using the Bionic C library. The init process is custom as well. It relies on init.c files to stop and start services. And the inter-process communication, or IPC, is also custom and is called binder. Most of those choices were made for licensing purposes, trying to avoid the GPL license as much as possible. But so everything else from the Java UI framework to the system server or the hardware abstraction layers have been written especially for Android. It doesn't mean that Android doesn't rely on open source projects. On the contrary, there are many of them. If you have the Android source code in front of you and look inside the external folder, you can see that there are many available open source projects, such as WPA Supplicant, which is the Wi-Fi stack usually used in Linux and also in Android. But there are also other differences when it comes to comparing Android to Linux, and that is also inside the file system layout or even the custom partition layout. So what it means is that you won't find a /user/bin like you could find in your Linux system. Instead, it's all been split into different partitions like vendor, system, product, and so on. And this partitioning is also different whether you use an AV devices or non-AV devices. We're gonna cover that topic a little bit later on. The same goes for the build system. It doesn't match anything that has been used on another Linux distribution. It is custom based. It used to be Makefile based, but is now using the SOM build system. But then one of the key interests of Android is its security. It's all started with the first release of Android that already had that in mind with the application security. So each application is running with its own unique ID and its own sandbox, so that we make sure that the application doesn't have permission it shouldn't have. And also there is a signature process which allows you to control that. For instance, if you want to update an application, the signature is the same. And the signature is also used to control like accesses to some specific API where an application signed with a platform key versus an application signed with a developer key doesn't have the same accesses. Then along the way, the Android team brought the SE Linux, which is the Security Enhanced Linux project, which defined access controls for the processes and files. That means that even if your user ID could have access to a file, if it isn't inside the rules of SE Linux, it can be denied, and so your access can be denied. So that allows the OS to give another layer of security as to what the application can access and cannot access. And the final addition was to use the Trusted Execution Environment OS, which is for ARM processor, the Trust Zone, to do all the security inside that part of the CPU, which is in the secure layer, and that allows to do all the security like key operation and stuff like that in the secure layer, so that the rest of the CPU cannot see any of it. It is used in different components, which are the keymaster, the gatekeeper, and AVB. That is what is used in your phone most likely. Then even the boot process is specific to Android. On a standard Linux system, the kernel, the device tree, and the RAM disk are located on a regular file system, whereas everything is packaged inside a specific image in here. So for instance, the Android boot image includes the kernel, the device tree, and a RAM disk. The Android DTBO image includes several device tree overlays. And this is very specific to Android. Then it also added something called the boot control block, or BCB, which is basically the communication between the OS and the bootloader, as there was no equivalent in the Linux world. So basically here it is used when the OS wants to, for instance, reboot into fast boot mode or reboot into recovery. It writes something to the boot control block, and then the bootloader can read that message and do what is necessary. And finally, as part of that boot process is the Android Verified Boot, or AVB, which checks the authenticity of the binary that you're loading on your system. So basically, checks the chain of trust of your system. The way it works is that it uses the mVerity to check the integrity and check the hashes compared to what is inside the specific partition called BBMeta. So now that we've seen the overall architecture, let's have a look at the pros and cons. And the main pro argument when using Android is definitely the app development. It is the best environment you can get for app development. It has a great BSP and app dev separation, meaning that to do your app development, a developer doesn't need to know anything about the BSP. All he needs to have is the SDK from Google and the NDK. So the SDK is for the software development kit, which provide the Java and Kotlin API, whereas the NDK provides the C++ native APIs. And with that, you can do your application without needing to know anything about the lower layers. And with that comes all the tools necessary to complete that work. And that starts with the Android Studio that is here, like you can see on the right side of that slide, to help you develop, deploy, and debug your application. So you can do a step-by-step. You can do that also across different languages. So you can do that. You can debug the Java layer, but also the C layer in your JNI, and it all works like seamlessly. They also have an emulator, which is great to get developers started without having the actual hardware, for instance. So you could use an emulator of Android and do your app development there, and only test like the final product on the hardware itself. And also, like, all those tools are working on all the different OSs, whether you use Windows, Mac OS, or Linux. And with that come a lot of the different debugging tools, but the main one being ADB, which is the Android Debug Bridge, which allows you to do everything I just talked about with simply a USB cable. So all you need is your platform, a USB cable, and then you can connect and talk to the platform and load your application and debug it on the platform directly. And all of those tools are only like as good as their documentation, and the documentation is great. You can go check it out on developer.android.com, where you can see that everything is explained, all the APIs. They also have like a lot of different examples. The Google team also provides like some repository with sample applications where you can see how to use a specific API, like the connectivity, the media, the camera. And on top of that, since it's so much used like across the globe, really, if you have something you're not sure about an API, you just Google it, and you're gonna find the answer to your questions. And also, we talked briefly about the Google specific application like the App Store. And since there is so much traction around Android, you know, there are some alternatives which are open source, like F-Droid that I talk about it here. It's another app store that you can use and app on your platform, which is open source. and everything is open source from the server to the client, so you can create your own app store and select the application that you want to put there and create your own client so that you can control really what your product includes or not. And finally, there are many developers available. If you're looking for team members to do like app development in Android, it's going to be easy to find it. On the cons list is the PSP development. It's not so easy, and we're going to go over some of the reasons why. First, I would say that the source code is huge. Like if you sync all the repository of Android to be able to build your own image, you have to know that it's going to take first it's going to take some time, and in terms of storage, it's going to take about 100 gig just to get the source code, and then it's going to take another 100 gig just to build that source code and make your own image without any modifications. And so having that source tree that big is a bit challenging for many people, and it's also easy to get lost inside all those projects. I didn't count like how many projects are included, but there are like hundreds. And so to do that, we recommend using a code search website that allows you to, like, for instance, look for logs and so on. So we provide the links for 2 of them that can help you navigate through the source code, but it can still be like intimidating for the newcomers. Also, the BSP itself is very, very dependent on the silicon vendor. So depending on what support the silicon vendor you've chosen is providing, you might end up with half-baked Android OS, because many of the components, like the graphics, for instance, needs to be done for Android specifically. You cannot use a graphics library that is meant for Linux on Android. That's not the way it works. So you really need to make sure that the silicon vendor provides a good BSP, a good base BSP. And then in terms of the resources available to do that BSP development, it's not the same as the application. For the application, it's easy. There is one API for all, and a lot of documentation. A lot of people have been using that API, so a lot of resources. On the BSP side, on the other end, the documentation is getting a lot better, but it still requires a lot of diving into the source code to understand what's going on. And there is really no way around that, because the BSP code is really like low level and depends on each CPU and platform that you're using. So there is no documentation that fits all the needs possible. But yeah, so once again, that can be a drawback of using that. And unlike the application developers, it's harder to find people that are comfortable working on the BSP side. And then the final thing about the BSP development is the system updates. The main thing about embedded project is that it usually requires something that's going to run for like 5, 10, 15 years. And it used to be a big challenge to update one Android code base to a newer one. So that is often a question that we received about, okay, what's going to happen in 5 years? Are we going to be able to update the Android version and so on? And so this is still a work in progress thing. Google is trying to fix that, as they want to stop the fragmentation of their version of the OS across the mobile. And so that work also applies to what we do in the embedded space, obviously. And the project Treble is here to help you move version more easily, like as easily as it could. And then the final thing is the resources requirement in terms of hardware. As I know, like customer like having numbers. I just started Android 10 on a i.MX-LM platform, and the result is that it takes 1 gig of RAM at boot up. So without doing much, it's just showing up the launcher application. There is already 1 gig of RAM being used. So it means that if you plan on using Android on a 1 gig device, it's going to be very challenging because you're going to be running out of memory pretty much all the time. And the reason for that is that Android 10 comes with 160 different services at boot up. And we often receive questions about but can we get rid of the services we don't need? The problem is that then it breaks the API and it can break the OS behavior overall. So it's not an easy task. So it is something to consider, the amount of RAM, but it can be something that is not as important because, for instance, all our LM platform by default are shipping with 2 gig of RAM, which is plenty of RAM to run Android on. And we have the same thing about the storage. If you try to have the tiniest storage possible, it's going to be challenging, as you need at least 4 gig, and we're really recommending 8 gig. 8 gig and above is really what we recommend to use Android. And then finally, the hardware abstraction layer support, which is both pros and cons, because the pros side is that it's great for your application development. Definitely, it's great because it gives like a common API and access to your hardware. So that is great in that regard. And the cons is it depends on, once again, on the manufacturer of what you want to do. So here's an example that you can see on the right. We integrated an LTE modem inside our build, and that was on the pro side because that was a modem from Quectel, and Quectel provided the hardware abstraction layer. We integrated it very easily, and it worked right away. Right away, it recognized the LTE network, the signal strengths, the network provider we were using, the pin, and everything was working. And so in that case, it's great. It can be a different experience if the manufacturer didn't provide the hardware abstraction layer at all. And note that it also depends on which hardware abstraction layer we're talking about. For instance, for the sensors, it's easier to, if there is only like the Linux kernel, it's easier to make your own hardware abstraction layer for it. There are plenty of examples online, it's easy. But for some subsystem, it's harder than that. So you have to keep that in mind when choosing your hardware as well, that everything can fall into place. And finally, hardware abstraction layer is good, but it doesn't exist for every subsystem. For instance, if you want to use the CAN bus, there is no CAN bus hardware abstraction layer. So how do you want to handle it is up to you. So to understand the pros and cons, we decided to do some case studies to show like when we used Android and why, for fully understand it. So the first one is the access control that we use in stadiums here. You can see on the right what the device looks like. It's a simple device with a 7-inch touchscreen display, barcode scanner, NFC, and Weigand. And so why would we use Android for that project? Well, the reason number one was there was an existing application that we could reuse, and that only took a few days to adapt to our platform and to make it running as we wanted. So that is the reason number one. Reason number two is that you have to know that Android offers something called the kiosk mode that allows you to have only one app running at the time. And so that way, when you do that, there is no way for the user to go to the settings or to change anything of your platform. It's really just one application running. So that is great for embedded products. And also the customer wanted to leverage all the security features that Android has to offer, starting with the verified boot, with the application signature and build signature to make sure that when you OTA an update, it is really meant for that device. And still on that topic, still on the access control, just to give you an update. So this device has been on for several years now. And we just updated from i.MX-6 to i.MX-8M, and also updated the code base from 8 to 10. And in that case, we already own the software. It only took us like a couple of hours to get everything running just like before. So that is the big advantage like when you upgrade something, it goes very quickly. Like as soon as the OS is up, running the application is a matter of hours. Another case study was Digital Signage, which required some HDMI monitors and simple like connectivity, Wi-Fi, Ethernet. So why would we use Android in that case? Well, in that case, that was simple. Is that it was relying on the HTML application, and so it needed a browser with full acceleration for both video decoding and graphics. And I don't know if you've tried that on the Linux side, but it's not as easy to find a solution that includes both video acceleration and graphics acceleration. But on the Android end, it's easy. Like as soon as those features are enabled at the BSP level, meaning that it can decode video by default and it can leverage the GPU to render the OS, then if you install any browser on that system, it will be fully accelerated. So that is why we chose Android in that case. Also, it was a dual monitor situation, and the Android includes an API called the presentation API that allows you to fully control the content on different screens. So it allows you to display different things on different screens. So that was a great feature here. And finally, the last case study is our Reg Tablet, which is going to be a reference design to be announced soon. And here it was really a no-brainer. So it includes like many of the things you can find in a regular tablet, like 4G, Wi-Fi, BT, NFC, accelerometer to rotate the screen. And it only made sense to use Android because it's a well-known UI. Everything was supported. And so if you give that tablet to anyone, they know how to use it because they know the Android UI. So that's really the goal here. And also, like, since it's for like meant for enterprise, you can add your own device owner and manager in place, so you can control like what people can and cannot do on the device, as well as control the app store that you want to do with the open source solution we talked about earlier. So now let's have a look at the solutions from boundary devices. So as we said, like, it is very important for to rely on the silicon vendor for the BSP, and that's what we do. NXP provide good BSP support, Android BSP support for their i.MX processors, with updates about like every 6 months. So we try to follow up. We currently have Android 10 available, and Android 11 is in development and should be available in a few weeks. On top of this NXP BSP, we do some specific enhancements that only us are doing, like the camera autofocus, which allows you to have like a continuous autofocus on the device, and you can also tap on a specific area so that the focus goes there. We also support like a dynamic display. By that we mean that any display you can buy on our website is going to be detected automatically and supported by the OS. So without changing anything on the OS, with the same image, this same image will be able to run on any of our display that we support. And we also provide that display rotation capability, where if your display is portrait by default, but you want it to look landscape, we can set that up in the bootloader, and then the entire OS will run like this. We also have some accessories support, like we showed before, the EC25 LTE modem. And finally, we also integrate stable kernel releases for better security. Now, our BSP is once again a base BSP, and it comes with some limitations that we want to make clear here. And the first one is that the fact that we use the mainline U-boot. And the reason for that is that we want to offer the easiest experience to our customers, the plug-and-play experience. And when we sell off-the-shelf the devices, we don't know if the customer wants to use Linux or Android. And so our goal is to use the exact same bootloader, whether you want to use Linux or Android. And the good thing with that is that the mainline U-boot supports some of the Android-specific features. For instance, it supports fastboot by default, so you can flash your OS image using the regular U-boot, so that works great. It supports a limited version of AVB, so Android Verified Boot. I say limited because it only supports like a software version of it to do the check of the hash. It doesn't use the trust zone, so that is why we do not enable the trust zone in our bootloader build. And also because the trust zone OS is different between Linux and Android. Android using TrustEOS and Linux using OPT. So we do not enable trust zone. And finally, the way it works for our U-boot to be able to load all our different images, whether it is Linux or Android, is to load a boot script that will tell it, okay, like you can get the OS from this storage and so on. And so to be able to do that and not break our Linux way of booting, we added a pre-boot partition, which is before the boot image of the Android OS, to allow you to do that. And here is a quick list of questions that we usually have from customers about how to do things with our BSP. The first one that comes to mind is how to access the hardware. And for that, we do provide some very simple examples on how to access GPIO, I2C, or UARTs using the JNI. So since we use the JNI as this is the simplest solution possible to do that in your application, you need to sign your application with the platform keys, which might not be ideal for your project. So the proper solution would be to create a custom hardware abstraction layer to do that, which with the SDK add-on. But Nicola will cover that in a few minutes. Then comes the question about the OTA. As we said, we have some customer with very small storage requirements, so we decided to stick to the non-AB system. So basically, when you use AB system, you're running, you have a duplication of all the partition. You have partition A and partition B for all the different partitions, and that allows you to update the other partition while still running on the first one and roll back and so on. So this is a great system, but it takes more storage than the non-AB system. So that is why we stick to the non-AB one. And therefore, we only have like a simple like OTA solution that we provided with our base BSP, which is provided by Freescale, the Freescale OTA application. And then we have a quick list of guidelines of things that people should do before shipping Android in their product. The first thing would be to enable secure boot, making sure that SE Linux is enforced, using the user build, using your own keys, and so on. And so if you have BSP people in your team, that is great, that they can take that on. But for anyone having questions, that is where we recommend our partner Kinetics that can help you with all of those things, making it the proper way and production ready OS image. So on that, I'm gonna pass it to Nicola to explain how Kinetics can help you going further with your design.
Thank you, Gary. Thanks a lot, and welcome you all. So I will be taking over here for explaining a little bit how to go to the next step with your Android and introduce you what we do at Kinetics. So the agenda today will be talking about who we are, introducing what we do for Boundary products, what are our products line to support our Android BSPs, and the difference between development and production operating systems. So a little bit about us. We are partners with Boundary since 2012, so we have a long story of projects and success stories. We are members of the Eclipse Foundation, in particular the IoT Working Group and the Edge Native Working Group. We are the main maintainers of Eclipse ARA, that is an open source embedded client for Hawkbit. Hawkbit is a backend for managing OTA, and is part of the Eclipse Foundation too. And we are committers on several embedded projects, SW Update, probably many of you knows the OTA client for Linux, and Yocto, kernel, and also U-Boot. We have a series of Android-related products that may help during our development to provide customers values on their use cases. In particular, we have SDK extensions that are a way to extend Android SDK that may not include many times support for low-level input-output, so that you want to control your GPIO, serial port, SPI, PWM, CAN, and Ethernet. You don't have a strict abstraction and API available on regular Android, so we fill that gap providing libraries to comfortably write your own Java and Kotlin code to deal with those input outputs. Then we do have a clustered high availability OTA system called Update Factory. Many customers of ours use Update Factory for their operating system updates and also for delivering application updates. Another product is the Vibe. The Vibe stands for Virtual Building Environment. Is our way to deliver source code to customers when we are done with a project, and is a bundle that provides all the building tools and all the source already built for you and tested and ready for you to take over. Last but not least, Coesis is our operating system that actually features the asymmetric multiprocessing. You're familiar with i.MX-7 back in the days, and now i.MX-8. They are featuring a microcontroller and a microprocessor in the same package. So for exploiting that hybrid architectures, we bake an operating system that actually may facilitate you to approach that architecture. One of the things that are interesting about Android is that many Windows C# developers move to Android because it's possible to use their own building tools for making Android apps. Xamarin is the framework that is now taking over with respect to the old WinCE approach, and now many Windows developers are writing Android apps using their own IDE and development tools. Kinetics, our SDK extension, so all our extension APIs supports Visual Studio. And so we have customers that are easily controlling their low-level hardware using C#. In general, our evaluation BSP for the boundary products, we actually have a list in our website. If you go and again, this presentation contains all the links that are needed for you to navigate a little bit what we are doing. So we have a list of supported products for your evaluation. When I say products, all the nitrogens boards that Boundary manufactures. Our blog called Technical Notes provides all the information about how to install the BSPs, the evaluation BSPs. All our BSPs also includes the possibility to use our own OTA backend Update Factory, and also we includes all the apps to evaluate the SDK extensions for you just to take a look at, and the app sources are on GitHub, and these are reference part of the documentation on how to use those SDK extensions. Of course, the support libraries for enabling these SDK extensions are licensed by Kinetics. Early October, we will be releasing Android 11 for the M-MIDI and the AM+, the nitrogen boards. We have already Android 10, but this is actually the latest Android we are releasing. Kernel 5.4. We do use Treble to eventually allows you to move to Android 12 using what is called Google Generic System Image. You're just like pushing the system image and you're not touching the kernel and the vendor package where all the vendor dependent code resides, but you can then have a brand new Android 12 user space for your evaluation. Of course, the Android 11 supports a double copy, so dual partition, as Gary was mentioning. And then we include, of course, the SDK extension evaluation apps that includes the GPIO, CAN bus, SPI, PWM, and serial port, serial communication support, and also the Update Factory service and app to evaluate the OTA technology we provide. Well, we do also support legacy products such as Nitrogen 6, Nitrogen 6 SOM in SOM module, and Nitrogen 6 Max. In particular, we have Android 9, and the Android 9 has been provided as a user build because it's a nice way to evaluate what the Android verified boot is capable of, and SC Linux. Of course, those nitrogens have a limited amount of eMMC and or SD card if you're using SD card, of course, space. So eventually, we provided the BSP with single copy updates capability. Same for the Nitrogen 7 and Nitrogen 6 Lite, where we have Android 7 with kernel 4.1 available. And as well here, we have single copy update available. So the old ways of doing Android updates through the recovery mode, many of you may be familiar with that. So we still support all these products from Boundary devices, and still those boards are used very much in production systems, and so we will continue to support those products also in the future. One of the things that we are going to do now is to explain a little bit more about what's the difference between a development system and something that is meant for production. One of the things that customers do as soon as they can is to try to isolate as possible their kiosk mode product and try to make the system as close and self-consistent as possible. For instance, you can disable bootloader screen outputs, remove USB input devices, disable logs, and remove the navigation notification bars, run your app in full kiosk mode, so you have the user faces just one app and everything is regulated by the app itself. And of course, you want to limit access to your Android settings, so you wanted to create certain connection between your app and a particular Android settings that you want to give your user access to modify some settings required for your application to work properly. However, Android is much more, and even if time ago, probably the UI capability was one of the most significant reasons why people was choosing Android. I think today the security pattern is much more what Android is bringing on the table. First of all, you can implement a full chain of trust. So starting from the bootloader, you can enable, of course, the Android verified boot through a subsequent series of signing requirements. So in your booting sequence, every steps basically provide you the right way of accessing that to the next one. So everything is codependent. If one signing process is not verified, of course, the operating system is not booting anymore. It sounds complicated, and it is a little bit complicated, but right now, because Android is a very used operating system for consumer products, actually security is pretty important. One of the things also that we want to mention here is the trust execution environment. That is some important step that ARM actually provided to the community, and is a way to manage your secrets in a very secure way, very close to the silicon. So basically, when you do develop your system, you don't want many of those things in your way. So you want to disable all those security things that may block your debugging and testing. So VM Verity as Linux will be in permissive mode. You want an unlock bootloader so that you are able to push any image and not chain of trust involved. And so Android Verified Boot disabled too. You want access to all the debugging options. So serial port and ADB will be available, and ADB also give you the possibility to have access as a root user to your Android console. And of course, you don't want to restrict any access to peripherals and drivers. And you want to make them accessible for any application. This is what you want when you are developing software. Of course, when you're going to production, these things may change. You want to get a little bit more isolated, as I said before, and you want to generate your own production keys for signing your chain of trust. You want to enhance your siloed environment, creating your custom launchers. For instance, if your kiosk mode applications fails, you have a fallback where your system can safely go eventually to update the operating system or the application and create what we call the maintenance mode. And then you want to, of course, enable SE Linux to have a more restricted access to hardware. You want to implement the full chain of trust and store your secrets eventually on the trusted execution environment. Gary showed this image, probably now it makes more sense to you. Basically, a production image should always be locked, and you don't want anyone to actually inject other images on your system that are not signed with your keys. And so one of the things is for a production system to be locked and of course implement a sort of chain of trust. And in case the chain of trust is not fulfilled and there is some part of the system that is not trusted, of course, the rollback protection metadata allows you to land safely on the latest safe operating system that you have installed. And this is valid for AB systems, so system that carries on two different systems in the same storage. So this is another slide on Android Verified Boot. So again, here from the bootloader to the user data, everything is controlled by a series of hashes that are contained in this partition called VB meta that is signed by a key that is actually stored in the bootloader. Again, even the bootloader can be signed. You gotta use the fuse bit of your system on a chip, of course, and this actually will take you on implementing the full chain of trust. Let's talk about a little bit our business model. So customers in general can register for free in our website and download our evaluation BSPs binaries. But someone that wants to go to the next step and go over some sources purchasing, they may want to do some custom work with us to actually do some analysis of their specification, and then eventually use some generic products, and everything would reside in what we we call the virtual building environment. We have one of those for every single project of our customers. We offers also to host their building environment so they don't have to take care of it. Of course, any time they need a new build or a new feature to be developed, we are able to do that. Other customers may just want access to the BSP evaluation sources as is. but they want a complete self-consistent and tested building environment and source code. As Gary was telling you before, the source codes are huge. Just syncing up Android and make one build may require some time. Some things cannot go well if your hosting operating system is not configured correctly. So we cut that and we do that for you. And so some customer that has internally some Android operating system team, they want to just fresh sources that we tested for them, and then they can take over immediately on the project. And the way we deliver those virtual building environments are through AWS. So there is a really quick way for you to take over the building system and the sources to go on your own. So a summary of what we do and what our service is. We provide evaluation Android OS binary images for all the Boundary products, new products. So everything that is based on the 8M family of processor, M mini, and M plus family of processors, but also legacy products like all the i.MX-6 portfolio and i.MX-7. We also provide custom Android for design specific products. We do, of course, kernel development, and we customize the abstraction layer for supporting eventually new hardware. And also we provide custom launchers in case is required by your kiosk mode system. We provide all the security for production systems, so support for Android verified boot and the trust execution environment. We have already Android 10 running on the Nitrogen 8 and Mini featuring for a customer the trust execution environment. And of course, the full chain of trust, where we are also signing the bootloader for the complete chain of trust. We have an update. An OTA clustered high availability OTA system called Update Factory. Many customers are using this service to provide application update or operating system updates. They use that in development and in production. In development for delivering different flavors of the operating system to test to devices without going through a first flash, manual flash using fastboot, and of course in production rollouts. Update Factory has really interesting features for also doing partial rollouts for testing on different targets, the production builds. And finally, Vibe is our way to deliver source code for evaluation and custom operating systems, but also traditional source transfer options are available if customer is not interested on using the Vibe. Some useful links. Our website. If you guys want to request this presentation, just please send a request at info@kinetics.com or go into our contact form on kinetics.com and you will receive this presentation. Go to our GitHub and take a look at what we do. Our technical notes, our blog with all the documentation about all the BSPs notes and instructions on how to flash those BSP on the boards. Our section for all the Boundary devices BSP available on our website, and of course the page on Update Factory at kinetics.com/Update Factory. I guess this is everything on my side. I think that we have still some time for Gary to go through some Q&A.
Thank you, Nicola. So yes, so now is the time. If you have any question, now is the time to ask it. I already answered some question on the interface. So I'm gonna read them out loud here. So can you support GMS with your Android release? So basically, GMS can be integrated, but it requires the final customer to contact Google directly to get access to the GMS packages. So it requires an agreement with Google and so on. So this is on the end user and customer to do that. The other question is, do you have support for 5G modem on your roadmap? Actually, we haven't found like a 5G MPCIe module yet. The thing is that, as you can see on our platform, we often offer like MPCIe modules, MPCIe slot at least. So that's how we did the modem integration, by using the MPCIe. So we haven't had the opportunity yet, but for sure someday we could have some 5G modem integration. Then can the CAN bus be supported with Android, and how does it work with Android Automotive? So, well, first of all, like for CAN access, the way we integrated it in our base BSP was to use the CAN utils libraries, so that those are available natively and through JNI basically. But as Nikolai said, the Kinetics is also providing a proper SDK add-on. But by reading the question and checking the source code, indeed, the Android Automotive includes the specific hardware abstraction layer for the CAN bus, which isn't included in the non-automotive build. So we will investigate like what would it take to use that. But yeah, it is not there by default if you're not using the non-automotive build. And final question is more info about the kiosk mode. So we did a presentation before where we talked about Android in real life. Feel free to send an email about that. We can send a link where we'll give a little bit more info about the kiosk mode, but everything is on Android's website, to be honest. It is not something hidden or anything. It's really all part of the regular Android OS. So I think that's it for the questions. I'm gonna give like a minute if anyone else has other questions. And so just to repeat that the slide deck is available. It's going to be available at the end of the presentation. Same for the presentation itself. It's going to be available on YouTube. And oh, we have one question about the boot time. Well, we haven't done any measurement lately. I would say that without any optimization at all, like right now, if you boot the OS from like a cold boot, I think it would take up to 30 seconds. But yeah, it doesn't include any optimization in our base BSP. I don't know, Nikolai, if you've done some work around boot time on Android, if you have any figures to provide.
Well, actually, we did. We presented at Linux Embedded Conference, I guess, a couple of years ago before the pandemic, a solution that was actually leveraging the hibernation, so the suspend to disk, and that we were able actually to boot in 10 seconds. This solution, though, is very custom, and sometimes it's very expensive. So we did for more an academic kind of interest, but there are a lot of showstoppers along the way to implement an hibernation suspend to disk on Android, mostly because sometimes, again, is very vendor specific and very Android and kernel, so kernel version specific. So we did that. It's possible to do that, to bring down to 10 seconds the boot time to hibernation. But as Gary was saying, there are a lot of other optimization that you can do to actually bring your system up and running in 25-30 seconds. So, you know, but Android is like this. So many of those overheads cannot be actually changed so much. Android 10 introduced a lot of more services. More services are running now, and again, the system to boot all the entire framework actually requires quite significant time. It's just the price sometimes you have to pay for it.
Then we have a question about the sync and why is the sync so loud compared to a Yocto sync? Well, the main difference is that when you sync the BSP of Android, you're getting the actual source code of every project. So there are hundreds of projects and you're getting the source code for all those projects, even if some of the projects you don't need for your build. And so the main difference is that Yocto only has recipes. So basically for every project, it just needs one file that tells you like how to download that project and how to build it. So the first sync of Yocto is very slim because it's just recipe files and you don't download any actual source code that's going to be built. So that is why it's different between Android and Yocto.
That's a very good point, Gary. One of the things that Yocto does really well is layering the system. So you can do your meta layer on top of their existing meta layers. And so what meta layers may be needed to be updated for a new operating system compilation step. So Android, unfortunately, is not layered in that way. So even if you change something, you got to download the entire code and you got to compile the entire code. But again, with the right, for instance, we are using very powerful machine on our virtual building environment where with, let's say, 32 CPUs and a lot of RAM availability just for the compilation time, you can take down the compilation time to a few hours instead of a couple of days like it was in the past.
Okay, I think that's it for the questions. Thank you, everyone. Thank you for joining this talk. Once again, it's going to be available on YouTube, and the PDF is going to be available. Feel free to send an email if you have any questions, either to Boundary Devices or Kinetics. And have a great day.
And again, sorry, Gary, if you want to receive those slides from Kinetics, just write an email to info@kinetics.com or goes in our contact us section in the website and just drop a request over there. Thanks for attending.